Good morning, everybody. My name's Kelly Glenn. Work for Airgas. I sell specialty gases and what's called micro bulk. For those of you that have seen big bulk storage tanks around, micro bulk's exactly what it sounds like. It's just a smaller version of a bulk delivery system. So kind of a crazy name, but it's descriptive and it works. So we're just going to talk about general gas safety today, cylinder handling. We're going to talk a little bit about high pressure cylinders, also about dewars. And if you have any questions, please ask them, because it's a whole lot better if it's interactive instead of me just standing up here talking. So objectives for today, understanding the properties of compressed gases, storage, proper storage and handling, what kind of regulators do we use on those gases, and then how to work safely with gases under pressure. So there's, I promise I'll try for this not to be death by slideshow. So what kind of hazards do we have in dealing with compressed gases? Physical hazards, obviously the cylinder can get tipped over. Some gases are explosive. We have explosion hazards. We have the hazard of an uncontrolled projectile. That's what happens if the cylinder gets tipped over and a valve gets sheared off or partially sheared off. Any of you guys y'all ever see Mythbusters? You ever watch that show? Okay, there's one episode. Does anybody see the episode where they actually sheared the valve off the cylinder? Get your attention, right? Okay, and so we talk about those things in the gas industry, but literally they built 2 cinder block walls in front of this thing and sheared the valve off of the cylinder. It went through both of them. So it will go through that wall, that person, that car, that whatever. You know, it's just like if when you're a kid at a birthday party and somebody gave you a balloon, or you're blowing up a balloon and you blow it up and you let it go, who wants to tell me which direction it's going to go when I let it go? Well, gas cylinders are the same way. Only that cylinder weighs about 150 pounds and it's got 2,400 pounds of pressure inside it, so it's going to move, and it's going to move in a hurry. Chemical hazards, asphyxiation, poisoning, anesthetic effects, and tissue damage that we can have. High pressure hazards. I mean, clearly, compressed gases, by the very description, we're taking those. If it's an atmospheric gas, we're taking it, we're compressing it, we're shoving large quantities of it into a thick wall cylinder. And one of the things I want you to remember is, if a vastly overused word in today's society, if you treat it with respect, you should treat it with respect, because if you don't, it can hurt you. And so I've been in this industry for over 30 years, and it's a safe package as long as you use it the way that it's intended. The problem that we get into is sometimes people just don't know, or no one's educated them. That's kind of the purpose of what we're doing today. So hazards of refrigerated liquids, cryogenic temperatures. Any of y'all deal with liquids, dewars, nitrogen, argon, okay, or even oxygen. So flammability hazards. Any hydrogen users in here? Maybe sometimes in GC work we use hydrogen for a carrier gas instead of helium, or hydrogen for an FID flame. Oxidizing hazards, we'll talk a little bit more about that later. Chemical reactive hazards. I had a conversation last week, had a conversation with a customer about fluorine compounds. And so, you know, when we're dealing with fluorinated products, sometimes the materials that we use to deliver them have to be passivated. They have to be made ready. So we'll take a mixture of fluorine, nitrogen, and we'll get that metal ready to accept those type products. So toxicity, corrosion, and asphyxiation. All compressed gases are hazardous because of the pressure in the cylinder. We've talked a little bit about this. An unsecured cylinder. Anytime that you have a gas cylinder that you're working around, always make sure that it is secured to something, and it's secured substantially. I've seen everything from a rope tied around a cylinder to a bungee cord. And as long as it's secure, if you're looking at, typically when I managed an air gas facility, if you're looking at one of my trucks and we're moving cylinders up and down the road, there'd be at least 2 straps on every bundle of cylinders. That's because if one fails, I want another one to be there to hold everything. And that's just industry safety training. We do a lot of that. So at our stores, we have Air Gas University that I tell them one of these days I'm going to letter at Air Gas University, but it's not. It hasn't happened yet. But we do a lot of online training, a lot of hands-on training. We have an emergency response team. In fact, we've got one based at our store here on Northside Drive. So there's an aero response team. What in the world is that? Because of the hazards that are associated with the things that we sell, we have to be ready to respond in the event that something occurs that's out of our control. Mechanical failure, something starts leaking, a cylinder of bad stuff, whatever bad stuff that is, that starts leaking here that might be in an area. Maybe it was getting moved from one place to another and it's got a valve that's leaking. Well, we've got a team of people that can come out, put on proper safety gear, deal with that, and in fact, in the things that we do, we will know more about it than the emergency responders will. Most of the time, if our guys show up on site, then the first responders will back off and say, okay, what do y'all want us to do to support you? So unsecured cylinders are a very, very real threat, and it's because, even think about it, if I've just got one, even this one, sitting here on a cart, it's secured with a chain, it's got a cap on it, it's a secure package. As far as DOT is concerned, the Department of Transportation, that cylinder is designed to take a fall off a truck at highway speeds with a cap on it and be a secure package. You shouldn't have to worry about it. Now, sometimes there are molecules inside the cylinder that might be sensitive to shock, like acetylene. Those molecules don't like sudden impacts. There can be a violent reaction when that occurs. But all in all, it's designed to be a safe package as it's presented to you for use. Compressed gas cylinders like a sleeping giant. It's not my slide, I promise. I got it from somebody else. No cost spared in the presentation of this. You can see the outside of it. It's not an easy thing to move. It's not an easy, if you've ever tried to move one, okay, it's cumbersome. And so move it with a cart. If you don't have a cart, find one, please, because I know you've probably seen our guys when they're placing a cylinder, tip it up on its side and roll it. I've seen guys that can roll 3 at a time back in the day, literally three cylinders in hand, kicking it with their feet, and can walk it from where it is all the way across the dock. But those guys have been doing it for a long time, and they're still likely to get harmed doing so. So we ask them not to do that anymore. As a matter of fact, if we find them doing it, we'll call them in the office and have a little discussion with them and say, here's why you shouldn't do that. And if they continue to do it, we'll give them some time to think about it at home, because we don't want them doing that. So weighs over 150 pounds, travels at high speed, can cause severe damage. We talked about the Mythbusters thing. Even at low pressure, flow from an open or leaking cylinder. Gas can flow from an open or leaking cylinder. We had an instance last week with a cylinder of hydrogen at a customer site that the valve wasn't leaking when it was in the closed position, but when they opened the valve, it was leaking around the valve stem. Okay, and so fortunately, when the valve got closed, it didn't leak, so we were able to close the valve and safely move it. Law says we can't if it's a known leaking cylinder. Then we call aero response team, and they come out and go, man, are you kidding me? It's just a hydrogen cylinder. They see all different kind of hazards, but I don't want you to think of it as just a hydrogen cylinder. So the next line from one of the coworkers is, it's a hydrogen cylinder. What do you mean just? So it doesn't matter to us if it's nitrogen. So, and I'll comment on that again here shortly. Pressure of the gas or gas mixture in the cylinder is indicated on the regulator, on the gauge. There's 2 gauges on this regulator. One is a delivery pressure gauge. One is a cylinder pressure gauge. So the cylinder pressure is always indicated on the higher scale gauge. It's a 0 to 4,000 pound gauge there. And just just because we'd ask you never to let a cylinder go completely empty. In the case of a nitrogen cylinder, how it happens in our industry a lot of times is a nitrogen cylinder is being used in a purge application. We're putting a nitrogen blanket on top of something else to keep oxygen away from it. If that cylinder goes completely empty and there's not a check valve in that line, then we have the ability to physically back whatever we're trying to protect with that nitrogen into the cylinder. Then when it comes back into us, we've got a different hazard on our hands. And so there are things that we do in the fill process to try to catch those things. So what kind of pressure relief devices are on these cylinders? Okay, most of the atmospheric gases that we talk about are going to have a burst disc, which is a frangible metal disc that if the pressure inside that cylinder gets too great, then that disc is going to release and gas is going to be directed out a series of ports that are on the side of the pressure relief device. We can take a look at that. I'll take the cap off that cylinder in a few minutes. We'll take a look at where that is. So it's either a burst disc, or in the case of a CO, propane, methane, or acetylene, there's going to be what's called a fusible plug. So it's got holes in it, but there's lead in there. And so that lead or a material is designed to melt at a specific temperature. So if that cylinder is exposed to a fire, an acetylene cylinder, for example, if it's exposed to a fire, what will happen is that fusible material will release. The gas will be controlled as it exits the cylinder instead of, to avoid an explosion is what we're doing. And so a lot of times if I had a cylinder against the wall and it was involved in a fire, what I would see is a cone that comes up right where the top of that cylinder valve was. So there are some that have reseatable pressure relief devices, like in the case of a liquid cylinder, a liquid nitrogen, liquid argon, makes that nice hissing sound when it's sitting there, or if it's, some of them have a different type of, a little different actuating device on a pressure release, and it'll release all at once and it'll do it very loudly and get everyone's attention around you. And so people that haven't worked around it, if I were around it, I'd probably not move when it did it, because I've been around it a long time. If it were behind me and I didn't know it, I'd jump just like a little girl. But lecture bottles don't have a pressure relief device. Poisons, some of those products do not have it. We don't want to release a poison in the atmosphere. Sorry about the pictures. What happens, refrigerated cryogenic temperature burns. It'll burn your hands, it'll blister your hands if it gets on you. Doesn't take very long at all for a burn to occur, a cryogenic burn. I'll go ahead and get off of that. Doesn't take long for a cryogenic burn to occur. Back in the day when I would do science demonstrations, I can take a hot dog, put it in a stand, stick it down for about 20 seconds inside liquid nitrogen, and it's frozen solid. And so it doesn't take very long to do a tremendous amount of damage. Minus 320 on nitrogen. Things freeze really quick. You got one set of eyes, face shields, safety glasses, very, very, very important when you're dealing with those things. Cryogenic gloves. I know it's cumbersome. I know you don't want to have it on. No one wants to have all that stuff on, but the safety of the situation demands it, the safety requirements. And just the expansion volumes of nitrogen and argon. Nitrogen 696 times to 1. So a little bit of liquid can make a lot of gas, especially in a confined area, so you should always be aware of that. Anytime we're trying to move liquid from one place to another, we're gonna be wanting to make sure that there's some type of relief valve in place. Something. We don't want to be able to trap liquid in an enclosed section of pipe or transfer line, just because that's the folks that build our microbulk and bulk tanks have a saying that you can't cheat the heat. Okay, the liquid's going to turn back into a gas. It's going to happen, and so when it does, we want to give it somewhere to go. Liquid dewars, other things, other vessels should not be filled to more than 80%. We want to give that gas some room to expand. So just because it's a 25-liter dewar, I don't want to put 25 liters in it. I want to give it somewhere to go, especially if it's a closed system. If it's an open mouth dewar, as long as you can safely move it without spilling it. but use the appropriate containers designed designed to be used with those specific types of products. You probably have all seen a dewar that's got frost on the outside of it, and so we'll talk a little bit more in a bit about making sure that you understand how those containers work and what it means. But if you've got a big giant ice ball on the outside of one of these things that hasn't been in use, then there could very well be a vacuum problem with that container. And what we'd ask you to do in that instance is call Mel, tell him that you've got a dewar that's not performing, and tag it. We'll ask you to tag it so that we can get it out of service. Otherwise, it'll come back in and look like every other empty one that's out there in the yard. And in one of our fill plants, just so that you know, the fill plant that I'm attached to in South Georgia, in Albany, is a relatively small fill plant, and there's probably 40,000 cylinders on that site. So all different types of gases, all different types of hazards. Flammable hazards include hydrogen, acetylene, propane, butane, ethylene, and a whole host of other things. So I don't know that I need to give you guys a chemistry lesson. You guys could teach me some things about chemistry. Flammable gases in air, acetylene from 2.5 to 100%. Dangerous stuff. Acetylene likes to. It's quite reactive. Isobutylene 1.8 to 9.6%. Ammonia. Most people don't know that ammonia is classified as a flammable gas. In order to ignite, it's got to have an ignition source. And so that ignition source can be a lot of different things. It can be physically a flame. As we'll talk about in a little while with oxygen, it can just be heat. So, and note that the flammable range of a gas increases in the presence of an oxidizer. Should be stored separately from all your other gases. They shouldn't be stored with oxidizers. As a matter of fact, they ought to be 20 feet apart. And so if an ocean inspector, when something happens on an industrial job site and an ocean inspector shows up, one of the first things they're going to do is go look at the cylinder storage. If it's a compressed gas, if it's a gas-related incident, they're going to go look and see how it's, and if I had an oxygen and an acetylene cylinder sitting here on a cart that was in use in my facility, and it's chained down, it's cutting torch with a hose, that's fine. That's allowed by law for them to be sitting right next door, now, right next to each other. Now, from a safety standpoint, you can make the case that there ought to be something separating those two things in the event of some kind of incident. So they now make cylinder carts that have a 1/4-inch firewall that goes in between those two things. So segregate cylinders by hazardous gases. Incompatible things have to be stored in separate areas. And we just talked about 20 feet or a 5'6" firewall. Firewall's got to be above line of sight. So, and even in bulk installations, what we're required to do by fire code, by the NFPA codes, and by local fire marshals. Yes.
So if I have an oxygen tank and a helium tank, they should sit.
Oxygen and helium's fine. It's just in the around flammables. Okay, we don't want to keep an oxidizer in a flammable gas. Oxygen, hydrogen would be no. If you had helium and hydrogen and air that you'd be using for an FID, we don't. If you had an oxygen cylinder in the lab, we would not want to store even empties. We don't want to store empties because in our world we kind of view empty cylinders like people view empty handguns or an empty gun if you're hunting. Yes.
But we have a large open area lab that is not separated by walls, and we have a person working with oxygen who has to work in that lab, and it's an oxygen tank all by itself. But we also have an AC that is, within a couple of feet that has helium air.
Okay. And again, I'm going to go back to the in-use part, and from a safety standpoint, I'd tell you that if you had opportunity to separate those two things, we would advise it.
Like in a different room.
Well, it can even be in the same room. We just want to create separation. Okay, we don't necessarily want an oxidizer and a fuel gas.
Yeah, but then define separation. I mean, how much is separation?
20 feet.
20 feet.
Okay, that's what the federal government's going to tell me is they want 20 feet. And so if I got to give you a number, I'm going to tell you 20 feet.
Well, then the design of the lab is bad because when you store those tanks, there is no way.
Okay, well, I didn't come here to talk about architects and their design.
I'm saying
But
that goes against them.
yes, it does. It does. Okay, and so, all right, so food for thought. Okay, and how things are used. Yes.
The other thing is, I mean, there is full cylinders, there's empty cylinders. Now, at John Tech, I see all the empty cylinders going on a deck or on a ramp where they're going to be picked up. And at the point where they are kind of considered empty, nobody has a clue how empty they really are. They're sitting all in a big disarray. Yeah?
Yes. Well, and again, I guess I don't know if I completed my statement, but we consider every cylinder, we handle it as though it's full. Okay, or we should handle it as though it's full, because even when it's quote empty, it may still have 25 or 50 pounds of product. A lot of times I know customers that with helium that they're using for a carrier gas, if they're running auto samplers and somebody's going to run is setting up an auto sampler that's going to run all night or run over the weekend, they're going to come back and check on it some point later. They might change that cylinder when it still has 500 psi in it, because they know it's not enough to last through the weekend, so they're going to be preemptive and change it. Well, that's put in an empty pile, and now it's got 500 psi in it still, and so your point's well taken. I mean, yes, they're all out there, and even in empty cylinder storage, if I've got flammable gases and oxidizers, I should still keep those things separated as an empty cylinder. If just from a safety standpoint, from that same ocean inspector shows up, he's going to object to that too, because they're not 20 feet apart. And guess what? You know, I'm not going to go crack the valve on the hydrogen cylinder and see if it's empty. But yes.
I'd like to jump in on both of these previous points here very quickly. Most of the time, the architects will design with the fire marshal's recommendation in terms of how these fire separations are supposed to be set up, the distances between cylinders, trying to keep the gases that people are managing in mind. It's not a perfect process by any means. If you have a situation where you can't get that physical distance, the 20 feet that needs to be there, or there's not the firewall that's separation, then we need to try to look at some other way to, I guess, try to figure that out, whether that's moving that cylinder to another room potentially and plumbing it to it. However, we have to do that. With the loading dock situation, it's a little bit tricky. I know we've dealt with situations similar to this, like at the Bunker Henry building, for example, where you've got a large nesting of cylinders that occurs on the loading dock, for example, and most of the time they're empty. And again, that whole discussion of how empty are they, I don't know. But a lot of times we can figure out a way to get the physical separation that we need, whether that's building a firewall there or just creating the distance between them. So if you know of situations where this is occurring, especially in your lab, come talk to us about it, the EHS department. We're happy to try to help you find a solution that's going to keep you in compliance with whatever the fire safety regulations are, and we'll try to discuss it and figure that out and come look at your physical setup and go from there. Okay?
Right, and let me address my earlier remark. I'm not trying to. I know that it's not. You're right. It's not a perfect science, and everybody's trying to comply with things that in many cases are rapidly changing, or constantly changing, or being tweaked. So. All storage areas for flammable gas must have an AVC fire extinguisher within 50 feet of the area. I'm sure that that's not going to be, should not be an issue. You should have adequate fire extinguishers everywhere that they're needed in the facility, and you need to have enough space to move around. Forklift propane, I'm not going to talk about that. Oxidizing hazards. Anything that's higher than 23 to 25% oxygen, nitrogen oxides, halogens, chlorine, fluorine. Fires in an atmosphere that's enriched with oxidizing gases are hard to extinguish and can spread very fast. I've seen in the workplace, I mean, a lot of different applications, and I'm sorry if I talk about welding applications. I worked for many years in those, but in the summertime in the South, I've seen many times a guy that's got a cutting torch in his hand and 100 degrees outside, and he'll take that torch and stick it inside his shirt, pull that cutting oxygen lever, because that gas coming out of there, we get this nice little effect called a Joule-Thomson effect. Okay, if I'm taking compressed gas and shoving it through a small orifice, it's going to get cold when it comes out. That's just the way it works. And they'll take that oxygen and stick it in their shirt and pull that trigger and think, boy, that feels good. It's like I'm air conditioned inside my shirt. What they don't realize is it takes about 30 minutes for that oxygen to get back out of their clothing. And I might see that same guy 15 minutes later taking a smoke break. Never crossed his mind, never occurred to him that he was putting himself. Now, if I took, I've seen videos in the past where I can take a mannequin and I can expose oxygen through a hose, through a controlled environment, and put oxygen in somebody's clothing and then an ignition source, and it'll blow their clothing right off that mannequin. So oxygen is something to be taken seriously. Adiabatic heat of compression. So one of the things that happens when we take oxygen, specifically, well, any molecule, but in our industry it occurs mostly with oxygen. Compression causes heat. If you were in one of our fill plants and we were filling any gas cylinders in our fill plant, you'll see the guys out there on the line doing this highly technical thing. They're walking with an open hand, and they're walking down the line. They're touching every one of those cylinders. And the reason that they're doing that, they're putting a hand on here because when that cylinder's getting filled, it gets hot. Now we've got a temperature monitor on specific spots down the line. There's using a magnetic thermometer that's sitting on there. And he'll also, now we've got this cool technology where he can walk down with a heat gun and he can shoot that laser pointer and check each one of those cylinders. But when we're compressing gas into that cylinder, it's getting hot. That way we know that in our world, in the fill line, we know that every cylinder on that line is open. If we walk up on one that doesn't have heat, that has a valve that's open, we know there's a problem with that valve. So we'll close that valve and put a tag on it and walk away from it. We won't fill that cylinder that day. We'll pull that one out and send it to cylinder maintenance. So there's a nice visual. If I had just thought one more slide, I could have just shown you that. So we put thermometers on. What happens? Cylinders get warm during the fill process. We monitor those. We control that fill rate so that we can monitor the temperature. We don't want to expose that cylinder repeatedly to excessive temperatures because it can change the metallurgical properties of the metal if we did that. So we don't want to do that. So controlled process over an extended period of time. When a cylinder valve is suddenly opened, pressure slamming against a closed valve, even a distance of less than an inch. This is a co-worker of mine that put this material together, can cause extreme heat. And that heat can sometimes be an ignition source. Okay, and so anytime that you're opening a cylinder valve, and I'll say any cylinder valve, but specifically, especially oxygen, always slow, very slow. But it's just, I mean, it's part of my nature. If you see me open a cylinder valve, I'm just going to crack that thing where I see that gauge needle begin to move, close it, and then ease it again. I'm going to open it, close it, and then hit it nice and smooth. I want that high pressure gas to hit those surfaces in a controlled manner is where I'm getting at. Limiting the velocity that oxygen is traveling and trying to avoid that adiabatic heat of compression is one of the things. Regardless of the distance, we want to make sure that when that oxygen molecule hits a dead end, that we're doing it in a controlled manner. Oxygen flash fire, we've got to have an ignition source of fuel and an oxidizer. Or those 3 points of the fire triangle come together, we can have a detonation. The ignition source can very well be the heat caused by the friction of the molecules. So, again, in any valve that you're opening, restrict the gas flow so it can't flow at high velocity. That's why I said when I'm opening that valve, I'm just barely going to open it. And then that's a cylinder that was involved in an oxygen flash fire. Hydraulic hose was used. In other words, an inappropriate hose, a hose that wasn't rated for the service. And that's what occurred here. I've seen many different things over the years, but here's what I want you to keep in mind. Even when you do everything, sometimes there are still mechanical failures. Okay? And so the idea is to do things to limit your exposure to a hazard. Customers transferring product from one cylinder to another. We don't like to talk about anybody doing that. There's not any real legitimate reason for anybody to do that. I can tell you over the years that we've had customers that do it. Sometimes they do it without thinking about the possible consequences. We've had people that didn't want to carry 2 cylinders to a remote job site, so they thought about mixing fuel and oxygen together. Thought that'd be a really good idea. Wouldn't take very long. About the time they cracked that oxygen valve, it'd all be over. So oxygen flash fires, again, one of the most dangerous things that we handle. A lot of customers use oxygen. They happen very fast. By the time you realize a fire, by the time you realize there's a fire, it can already be over and out. So just some articles of clothing that were involved in oxygen flash fires and detonations. And again, as we talked earlier, if the clothing becomes oxygen saturated, it can burn very, very quickly. Gloves can detonate. This is what kind of glove that I use handling cylinders. Just a plain leather. It's called a driver's glove. Yes.
Is there you may talk about this later, but is there a certain type of regulator that you need for an oxygen tank? So I know for like a hydrogen tank you need an excess flow valve, or a regulator with an excess flow valve, whereas like gases like argon and nitrogen, you don't really need that, you just need a regular regulator. Is there a specific type of regulator that you need for an oxygen tank?
For oxygen, I would tell you that yes, you want to make sure that all the components of that regulator are compatible with oxygen. In fact, if you look at our website, airgassgcatalog.com, there's a compatibility chart back in the back. And so the issue that we get into, and we haven't talked about this yet, but talking about things like cylinder adapters. People that have, and a lot of times, and it happens in a university setting, you've got a drawer somewhere that's got a drawer that's full of regulators down there. Well, I need a regulator. I need another oxygen regulator. And so before I say anything, I'm not trying to sell anybody regulators. We sell them. Y'all all know that we sell them, but that's not my purpose for being here today. My concern when you reach into that drawer is what other gas service has that been in? Okay, and does it have an oxygen CGA on it? The Cylinder Gas Association connected. Does it have the correct connection? If it does, then if you bought a regulator from us, it likely would tell you that it's clean for oxygen service if it's an oxygen regulator. My concern would be that it had been in some other kind of gas service that was not compatible with oxygen. People do change CGA connections on regulators. We don't like that either. And from a corporate standpoint, we don't like it for safety purposes. We also don't like it for liability purposes. We'll design something and tell you, yes, this is an oxygen regulator, but when somebody modifies it, it's kind of out of our control. So gloves that have synthetic surfaces can easily detonate. Gloves that are dirty. Okay, I can't tell you how many times I've seen a guy with an oxygen cylinder that's got an oily, greasy pair of gloves. So we've actually had people. Some of the old regulators will have the gauge will say use no oil on it. I thought that was pretty effective till somebody called one day and wanted to buy some, and I said, some what? And they said, some no oil. I need some no oil. I need a container of that because it says that's what I'm supposed to use. That thing's hard to screw on. No. Use none. Don't use any. Sorry, bad joke. It's a true story, though. Valves should be a type that open slowly. Not a ball valve. Ball valve, wide open with one fell swoop. Okay, especially if I'm dealing with oxygen, I don't want to put any kind of valve in the gas stream that allows me to let those molecules get excited. So almost. You see, they never used in an oxygen system. By design, they're designed to give you a lot of gas quick, so we don't want those in an oxygen system. It's just a picture of a pigtail that failed, and you can see the pigtail was controlled by a ball-type valve. And so what happened? Somebody cracked the valve, and heat of compression, flash fire. occurs. Look at the top of that cylinder. It looks like, I mean, it looks like somebody just cut it out with a cutting torch. That's exactly what happened. I mean, you have an ignition that happens. I mean, they didn't literally cut it with a cutting torch, but I mean, that's what a cutting torch is, just a controlled mixture of flammable gas and oxygen. And when you hit that cutting oxygen lever, there's a stream of oxygen that literally oxidizes that metal and makes a cut. But so once they burn, they're going to burn as long as there's pressure. Fire started ball valve, burned its way back to the cylinder. Reactive hazards. Acetylene we've talked about. That's in our industry. That's the thing that comes up most often. And people that are using acetylene of up 15 psi G. There's a red line on that regulator, and it's there for a reason. It means don't go over it. Doesn't matter if you've been going over it for 25 years or 30 years. I'll just tell you, you've been very lucky. So those molecules don't like it when you start delivering them higher than 15 psi. They get really excited and become quite unstable. Corrosive hazards, ammonia, hydrogen chloride, and chlorine are some of the most common that we deal with. So they can attack body tissues. They can also attack and corrode metal. Toxic hazards, very specific to what kind of toxic product you're being exposed to, the concentration, the length of exposure. What's the manner of exposure? BF3, chlorine, carbon monoxide, fluorine, hydrogen cyanide, hydrogen fluoride, all different manner of those type things. They all have safety data sheets. There are specific hazards associated with each one of them, and if you're not certain of any of those things, I would refer you to the product safety data sheet. Inert gases and asphyxiation. All the things that we've been talking about today, people often ask me, what's the most dangerous thing that you sell? You know, we sell a lot of different chemical compounds, and they're usually surprised by my answer. And my answer is nitrogen. And they say, well, nitrogen? Wait a minute, that's an inert gas, right? Okay, but in our world, when we see an issue that has occurred with nitrogen, what happens if I walk into a room and my coworker has been overcome, the nitrogen has been released into the room and it's pushed all the oxygen molecules out. There's not enough oxygen left in that enclosed space for someone to stay conscious. Okay, if I walk into a room and I see somebody on the floor, what are we going to do? We're going to help, right? Because that's the way that we're wired. And so another person goes in to help, and you know, you can be overcome by an oxygen deficient atmosphere in about 30 to 45 seconds, depends on. It doesn't take very long. So one of the biggest concerns that we have is using inert gases that have the ability to asphyxiate someone in an enclosed space, whether it's nitrogen, whether it's helium, whether it's argon. Seems, you know, it's not reactive. It's people kind of take it for granted. And so in our world, when we're investigating incidents, a lot of times it's that gas. And my reason for saying it's one of the worst things is because nobody's afraid of it. And if something happens, it usually harms more than one person because we have that desire to go offer assistance. So, and I don't think that, I'm not going to play that YouTube thing, but it's a very interesting thing. It's an experiment that somebody did with air gas keeps me from, on my computer, from being able to play YouTube videos. But what it is there's a researcher that has a pig that comes into, there's a bin with some apples, there's a nitrogen hose right above it, and what they want to show is that it doesn't harm the animal and how quick that animal can recover from it. So the pig runs into the room, looks and goes, hey, apples, and sticks his little snout in there and starts eating the apples. Well, there's nitrogen in there, and he's breathing the nitrogen, so he quickly stands back, kind of staggers, and falls over. And after he's out of the nitrogen deficient atmosphere for 15 seconds, 10, 15 seconds, he kind of starts coming to, and he stands up, And he looks at the bin and goes, hey, apples. And he goes and sticks his head right back in. And so, you know, the point is it didn't harm him. It didn't hurt him. There's no pain associated with it. You just go sleep. And so I've seen a lot of things over the years. Researchers, there was one guy that went all around trying to find, if I were trying to kill myself, what's the best way to do it? And he got hooked up with some people in the U.S. military, and they started showing him what happens when you start choking off reducing the oxygen percentage in the air that you're breathing. And have you guys ever seen one of those, it's a little like I'll call it a Tupperware ball. It's like a play ball. It's got the little infants use, okay? This little ball's got different shapes in it, and the kids learn, okay, there's a round hole, I'll put the round thing in there, and it falls right in. All right, so they gave this guy, okay, here, this is one of the tests that we're going to do. We're going to start reducing the amount of oxygen that you have available to your brain, and we want you to work this puzzle. And he said, man, whatever you give me, I'm going to blow right through this stuff. And so as it goes on, they're creeping down the oxygen content, and he's trying to, I mean, at first he just kind of gets confused when they start reducing it. And he's looking at it, and he can't figure out which shape he needs to put in which hole. A few seconds later, he starts laughing hysterically because clearly it's funny that he can't do this. And about that time is when they started giving him oxygen. The doctor says, all right, bring up the oxygen level. He asked the question at the end. He said, okay, show me the video. I want to see the video. And he thought he had aced everything. And he couldn't believe that he couldn't work that little puzzle. And he asked the question, how close was I to being overcome? And the doctor said, you were about 15 seconds away. Within, I mean, you know, this is in a controlled environment. So nitrogen. Nitrogen is one of those things. Any kind of inert gas that has the ability to displace an oxygen in a room or an enclosed space, I'm really concerned about that. I'm concerned about all of it, but I'm real concerned about that because it's a real hazard. So one of the things we're going to talk about is don't worry about the color of the cylinder. If you buy specialty gases from us, most of them are in a blue cylinder. And they all look alike except for the neck ring at the top. Neck ring's probably painted a different color. That's kind of for us to be able to know internally how to segregate that thing. I'm going to tell you to read the label, read the label, read the label. Always read the label before you hook it up to it. And if you're taking that regulator up to something and it doesn't fit, there may very well be a reason why it doesn't fit. Because different connections for different types of gases, regulators are designed, made with different materials, to go back to your question earlier, so that they are safe for you to use. So if it doesn't fit, don't use it. There's a reason it doesn't fit. So if there's any doubt about what's in a gas cylinder, don't use it. If the label's been removed and it's a green cylinder, it doesn't mean it's oxygen. Okay? It means call Mel. Mel, I got a cylinder, I can't use it. It doesn't have a label on it. Okay, we'll come get it. And then we'll make a determination on what we think was in it last so that we can legally move it. We'll look at the valve. We'll look at all the different indicators that we've got. You know, that likely tell us what kind of hazard we're dealing with and how we should label that so we can legally move it. There's one of those labels. Read it. Cylinder handling. Ensure that you have a clear path. Store the cylinder out of the walkways. How about this? Store cylinders away from heated equipment. You'd be amazed how many people will take an aluminum cylinder that's got, typically that's got a coating, a clear coating on the outside that's some kind of temple arm coating. If it gets exposed to high heat, it'll turn brown. You'd be amazed how many of those things we get back in with a nice brown streak on the back where somebody's rolled that thing right up next to a boiler or something. It happens more often than you'd like to know. Store the cylinder away from heated equipment. Give yourself plenty of room to be able to move around. Never lubricate the valves. Please don't do that. You know, sometimes it's hard to, you know, never lubricate a cylinder cap if it's hard to get off. Don't put anything on there. We don't want anything on that cylinder cap. Don't handle it with oily hands, gloves, or tools. Should always be secured on a cart. Yes?
Repeat the question.
What do you do if you can't get the cap off? Well, this is a cylinder cap wrench that was that was brought in for the presentation. That'll fit in the notch on the side of this cap, like so, and turn it. So, and honestly, we really don't like these very much. We really don't. I'd rather see a strap wrench, because a strap wrench will go around the outside of it and turn that. Sometimes this type of wrench can hit that cylinder valve, and you might cause another problem inside the cylinder, so just be careful when you do that. Should always be secured on a cart or a stand or up against a lab bench. Yes, I'm sorry.
I have learned that you're also not supposed to do Teflon tape around.
Yeah, as a matter of fact, when I looked at this one earlier, we brought this one in just to use as a prop. See that Teflon tape that's on there? Well, that right there should be there. That's got to be there at the where the valve screws into the cylinder. But up here on this cylinder connection, while we're talking about that, you should never have to use Teflon tape on a cylinder gas connection, on a CGA connection. You shouldn't have to. If it leaks, if you put a regulator onto that cylinder and it leaks, there's generally a reason why it's leaking. In the case of a CO2 regulator, 99 times out of 100, the reason it's leaking is because there's not one of those washers in there. And so I can't, we were talking about this earlier, I can't tell you how many times I've responded somewhere where they've got a leaking cylinder and can't make it stop. And when I get there, somebody's changed an empty cylinder. Did you just recently change the cylinder? Yes. The first thing I do when I get there is look on the floor, because most of the time that washer that's in there has fallen out of the regulator and gone down on the floor, and they've put, there's a flat seating surface on a CO2 connection. Right here on the end of this, that washer goes on the end, and then the nut secures it in place. It's a one-time use washer. It's not designed to be reused. So when CO2 leaks, somebody has reused the washer twice or 3 times or 4 times, and it's gotten crushed and won't make a clean seating surface any longer. But I'll go back to most CGA connections have a machined metal-to-metal seal. Okay, and so basically the end of this nipple seats into the cylinder valve, and then this typically is external threads and secures it in place. Well, that metal-to-metal seal between the end of this nipple and the valve should be adequate. And so there's no reason for anybody to put Teflon tape on a cylinder valve connection, and if they do, that's telling you there's another problem. Because if I drop this regulator on the floor, in laboratory settings, I like to see the regulator, I like to see it mounted on a bracket on the wall with a pigtail hanging here that hooks up to whatever you need to deliver gas to. The reason for that is because you've all seen this. When this is hooked up to the cylinder, and I've got to change the cylinder now. What am I going to do with this? Okay, hopefully the tubing's going to be hanging here, and I'm going to try to, hopefully I can get it back to the bench. Well, a lot of times we've got this nice mangled piece of tubing that's been bent, because somebody knocked it off the bench and it's fallen down and straightened it all out. It just creates a mess. What it does is it eliminates a hazard. So, see if we can keep going. Any other questions about? Yes.
Do you have any concerns about static?
Do I have concerns about static?
Yeah, especially like this time of year. Where do you ground before you go into the room?
That's a really good question. In all the years that I've done this, nobody's ever asked me that question. But yeah, I would with flammable gases, particularly much in the same sense that I would if I were if I'm fueling my car. I'm gonna get out and I'm gonna do this before I touch anything. I'm gonna create a ground, and I'm not gonna get back in the car. There are certain things that I'm gonna do to not create a hazard. And so yeah, it's probably a very good idea to make sure that you discharge in the wintertime, especially this time of year. Use a cart. I think I said that earlier. It's important to use a cart. Our guys are usually moving 2 at a time. Most of the time with a customer, if I were going to sell you a cylinder cart for moving a cylinder, it'd usually be a single cylinder cart, and I'd probably want to sell you one that has outboard support wheels, because It's not your job function to be moving cylinders. Suitable cylinder cart, we just talked about that. Hardest thing in the world to do. If the cylinder starts to fall, you got to let it go. You got to let it go. And it's everything in you wants to reach out and catch that cylinder and try to stop it. But if I do, that 150-pound cylinder that's now moving and gaining speed as it's falling over, and I'm trying to grab it, and my back's not as young as it used to be. It doesn't matter if you're young or you're not. The things that can happen, you can strain your back, you can get your hand stuck between it and another obstacle, a lab bench. Cylinder starts to tip and you reach to grab it and you put your hand in the wrong place, you might end up with a finger that looks kind of like that. It doesn't take, just takes that long for something to occur. But if a cylinder starts to fall, this is training that we give air gas employees over and over and over and over again. If it starts to fall, you got to let it go. Muscle strains, pinched, crushed hands, fingers, broken bones, and more. 6% of all the injuries that we have inside air gas happen because somebody gets a finger caught in the hole of this cylinder cap if they're rolling a cylinder. So ask me why we want to use a cart. It's just more secure. We always want to use a cylinder cart, but if they're rolling that cart, 6% of the guys that we have, my coworkers that will get injured, will hang a finger in that hole as it's spinning, and it'll break your finger, is what it'll do. Cylinder caps are not meant for lifting. I know I shouldn't have to tell anybody that, but I've seen people try to pull it up into a truck by the cylinder cap and the cylinder fall. I can tell you on two different occasions in my lifetime when I was trying to tell somebody stop, 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 and they pulled it and the cap came off and the cylinder clanked back down on the ground, and it thankfully rested on the edge of somebody's lift gate and didn't get the cylinder valve. I saw another guy do it one time where he was pulling a cylinder toward him, the cap came off, he hit himself in the jaw, knocked himself completely out, broke his jaw. Don't pull a cylinder, don't lift the cylinder by its cap. Never was designed for that. It's not designed. So don't roll a cylinder except for short distances. Okay, when you move it into a cart, you've now got to move it. You've got to position it and wiggle it back into the bracket. Okay, that's okay. But what we don't want is we don't want to see you tip it up on its side and kick it and roll it for a long distance. I don't want to see you do that, or I don't want to see an air gas employee do that. Avoid rough handling of liquid containers. Don't leave it in an open position when it's not in use. PPE, we hadn't talked much about this at all. Gloves, just a pair of leather gloves can be enough to keep somebody from breaking, from a laceration. If I'm moving two cylinders and they're, bing, they hit together, if my hand happens to be in between those two cylinders, just that impact can be enough to tear tissue. So a lot of times just a pair of gloves will protect you enough. Regulator operation. One of the things that we need to remember more than anything else, and I'm going to put this on here real quick. I'm not going to turn this on, but how about if I do it the normal way? All right, so we're going to have this regulator on this cylinder. First thing that we want to do before we turn it on is we'll make sure that adjustment knob is all the way out and that there's no pressure on the diaphragm. One of the other things that I want to do is tell you that if I've always got this cylinder valve in between me and the regulator, always, then I'm standing in the right place. Because if this regulator fails, it's either going to fail, back that thing all the way out. If it fails, it's going to fail this way or it's going to fail this way. If the gauge fails, it's going to that tube typically is going to fail to the back of that plate. But that just means I'm always standing in the right place. I can't tell you how many times I've seen somebody stand directly in front of a regulator and reach up and grab the valve and go to turn it on. Well, if the regulator's going to fail, going to fail one of those two ways. So just keep the cylinder valve in between you and the regulator, and you'll be standing in the right place. Make sure the flow control valve is closed. Slowly open the cylinder valve. We've talked about that time and again. And then turn the adjustment knob in to deliver your desired pressure. CGA connections specific to the gas type. Nitrogen, argon, helium, we can use a CGA 580 connection. That is a CGA 320 on that CO2 cylinders. That regulator won't fit. And again, if a regulator doesn't fit, I'm going to tell you don't use it. Just there's a reason it doesn't fit. Cylinders need to be secured. We talked about storage. Nesting of cylinders. In other words, nesting is if I don't have, I want to make sure that those cylinders are all making three-point contact. If they're in a storage area, that way if somebody bumps into them, they're all bumping against each other, and I don't have a cylinder that's now more likely to fall over. They've got something to push against. C2S2, cap, cart, safe, secure. Never move a cylinder without a cap. Never, never, never. Don't move a cylinder without a cap. Always use a cart if you have to move it. Always use proper PPE. And what is that? That's safety glasses. And we talked about those frangible metal discs, the pressure relief devices. Okay, if that thing, it's kind of like an airbag. Okay, and airbags, you know, you've heard in the news about particles, metal particles becoming projectiles from an airbag. With that frangible disc, if it blows, if it releases, there's going to be metal fragments that come out. Okay, and so if I'm around a compressed gas cylinder, I'm going to have a pair of safety glasses on. If I'm moving that cylinder, if I'm moving them, I'm going to have a pair of steel-toe shoes on. I'm going to have a pair of gloves on. If I'm dealing with cryogenic liquids, I'm going to have a face shield on in addition to safety glasses. So cap, cart, safe, secure.